Hey there, science enthusiasts and storm survivors. Welcome back to the channel where we ask the tough questions like, can trees actually fight hurricanes? Today we're diving deep into the surprisingly robust world of organic architecture, trees and plants, and how they stand up to the sheer brute force of a hurricane. We'll explore the physics, the biology, and even ponder the deeper meaning of a really bendy palm tree. Buckle up, because this is gonna be WiNDy. So, how do these leafy legends manage to not just get blown away to Kansas? It's all about smart design, folks. Think of it like this. A rigid building takes the full force of the wind head on, but a flexible tree, it's more like a seasoned limbo champion. Why did the tree break up with the wind? Because it was too clingy. Right, moving on. Species like our flexible friends, the palms, have trunks that can bend a lot. Their fronds also act cleverly, folding and reducing the surface area the wind can grab onto. It's nature's way of saying, nice try, hurricane, I'm doing yoga. Then there's the unsung hero, the root system. A wide, dense network of roots is like the ultimate anchor. Imagine trying to pull a house with toothpicks. Not gonna happen. Same principle here. And guess what? Trees planted in groups are even stronger. Their roots intertwine, creating a sort of leafy, woody Voltron. And let's not forget the tough guys, like oak trees. Their wood is dense and their branching is designed to avoid those weak V-shaped crotches that tend to split under pressure. These guys are the bodybuilders of the forest. Now for the million-dollar question, can a bunch of trees actually mess with a hurricane? The answer, surprisingly, is yes. It's all thanks to a little thing called friction. Imagine the wind is a super speedy, slightly grumpy river. Now throw a whole bunch of trees into that river. What happens? It slows down, right? All those trunks, branches, and leaves create drag, stealing energy from the wind. Scientific studies show that dense forests can reduce wind speeds by up to half. That's a huge difference in destructive power. What do you call a lazy kangaroo? Pouch potato. Relates to nothing. Just testing if you're still awake. And it's not just about slowing down. Trees also create turbulence. Think of it as the wind getting all jumbled and confused as it tries to navigate the forest obstacle course. This disrupts the smooth, powerful flow of the wind, scattering its energy and reducing the sustained pressure on anything behind the trees. But this isn't just about physics and biology, is it? There's something almost philosophical about a tree standing firm against a force that could easily obliterate it. It speaks to the resilience of nature, the power of adaptation. Consider this, a single tree might fall, but the forest persists. It's a collective strength, a community standing together. It's like nature is saying, you can throw your worst at us, but we've got each other's roots. Think about a coastal mangrove forest. These tangled ecosystems not only protect the shoreline from erosion, but also act as natural storm surge barriers and windbreaks. They've evolved over millennia to thrive in these challenging environments. It's a testament to the power of natural selection and the interconnectedness of life. It makes you wonder about our own resilience. Can we learn from the way these natural structures adapt and support each other in the face of adversity? Are we building our own communities with the same kind of interconnected strength? Deep thoughts for a windy day. So, the big question, could we actually plant our way to better hurricane protection? Based on the science, the answer is a resounding yes, with caveats. Planting more wind-resistant trees in strategic locations, especially in dense formations, to create effective windbreaks could significantly reduce wind speeds and thus the potential for damage. Think of it as building a natural infrastructure, a green shield against the storm. The mathematical probability suggests that a reduction in wind speed leads to an exponential decrease in wind pressure on structures. What's a tree's favorite drink? Root beer. Still got nothing? My comedic timing is clearly uprooted. However, it's not a silver bullet. It requires careful planning, selecting the right species for the local environment. Remember our flexible and strong examples, and allowing enough time for these trees to mature and form effective barriers. It's a long-term investment in resilience. So while trees might not literally punch a hurricane, they definitely put up a heck of a fight by bending, enduring, and collectively disrupting the storm's power. It's a beautiful example of how nature has evolved ingenious solutions to extreme challenges. What do you think? Should we be investing more in natural storm defenses? Let us know in the comments below. Don't forget to like, subscribe, and share this video with anyone who's ever been blown away by science or a strong gust of wind.